Hello guys, in this class we will continue to learn how to write query by SQL language. So we will learn the addition, deletion, and modification of data in the table with the subquery part. So remember the subquery we have learned in the last class. It is used in some query complex situations. So it means you can use several subqueries in the query language. So you can just query more information from multiple tables. So first, let's see how to combine the insert operation and a subquery. So in the previous class, we have taught if you want to insert some tuples in a table, you can use two functions. The first is you can use insert into table name, list of attribute name, and here you can write values. And you write values, you can write the detailed values according to these attributes. Is okay. The other way you can use is a subquery to write here. So that means you want to insert the query result of this subquery into this table. So such an insert statement can insert multiple tuples at one time. So you don't need to write the detailed values one by one. So for example, suppose there is a table engineer, and here the fields are extended from the relevant fields in the employee table, which we have shared in the previous class. So if we want to insert all the relevant information of employees with the title of engineer or above into this table, so we can write this kind of SQL language. So we can write insert into engineer, because here we want to insert tuples into the table engineer. So here we write engineer. And here we use a subquery to show the tuples which we want to insert into the engineer table. So here we can see we want to select the engineer, and then we want to select the title of engineer or above, and this employee's information such as employee number, employee name, title, and department number. So here, these information are from the employee table. So here we write employee, and the condition is their title should be engineer or above. So here we use an in to show the title should be in the domain of this range. And then let's see how to use update combined with the subquery. So the format is update table name set column name equal to expression. So here we have learned in the previous class. So using this kind of format, you can update some columns in a table with an expression. So here, if we add a where condition, which writes conditional expressions with subquery, so that means when this statement executes, all the tuples that make this condition expression with subquery true will be modified. So here, that means we add a condition here. And for example, if for the employees participating in the 2008 and 02 project, the value of the allowance in the salary table is increased by 2,000. So for this kind of query, we can write update salary stat, this rest is equal to rest plus 200. So the condition is we just want to update the rest of the employees participating in the 2008-02 project. So here we want the salary relevant employee number is in the domain of the employees which their employee number is connect with the item number 2008-02. So here we write on subquery here. So it is select employee number from this item employee table where their item number is 2008-02. Then let's see how to use subqueries in the set clause. Let's see another example. If we want to change the salary of all the engineers to the average salary of employees, how to write that? We can write this update salary set base pay. This base pay, we want to first calculate the average salary of employees. So here, to calculate the average salary, we can use a subquery here to select the average here. The average is a function to calculate the average base pay from the salary table. So here you can use this set base pay is equal to this subquery to change the salary of all the engineers to the average of the employees. So here, if we want to calculate the average salary in employee, here we need to use a condition which need to write in the where clause, where the employee number is in the domain of select employee number from employee where their title is equal to engineer. So here we write subquery as the query condition. So finally, let's see how to combine delete with the subqueries. The format is delete from. Here we write the table name, which is the same with the previous classes we have learned. And here, if you want to select some tuples from the query result of the subqueries, here you can write a where clause where we can write conditional expressions with subqueries here. So this statement will remove all the tuples that make conditional expression with the subquery true. For example, from the item employee table, if we want to delete all the tuples of Ding Wei Guo, we can just write delete from this item employee table. So the condition is where their employee number should be connected with the name Ding Wei Guo. So here we need to write a subquery to select the employee number from employee where the name is equal to Ding Wei Guo. So here we have talked about the insert, addition, insert, update, and deletion operation with queries. So finally, in this chapter, we will talk about the will, which is a very important part in our SQL language. So first, let's see what is a view. A view table is based on a query result, and a query that defines a view can reference data from a table, multiple tables, or other views. So the data corresponding to the view is not actually stored in the database, which we need to attention that. only the definition of the view is stored in the database. So we call data dictionary, where the definition is stored. And the query operations can be performed on the defined views, but there are certain restrictions on the view update operations. That means if you want to do the addition, deletion, or modification operations on the views, there exists several restrictions. So we will talk about detail later. And first, let's see what's the function of a view. A view is the data will point at the user level. So due to the view, the database system have the following advantages. First, views provide logical data independence, and it can make the user's focus, simplify, and customize your perception of the database through the views. And it also has other advantages. It has the data security protection function. It can be used as a security mechanism to enable users to access data only through the view without giving users access to the base table. And after creating one or more tables in the database, you can use the created view. This statement using the enterprise manager to create views. After creating a view, the query inserting, updating, and deleting data from a table can be done inside of table. So you can just do these operations on a view. And after the view creation statement is executed, the definition of the view enters the data dictionary, and the subquery in the statement is not executed. That is, the view is not actually generalized. Only when the view is queried, the data is retrieved from the basic table according to the definition of the view. So we can get a conclusion that views are virtual tables. It is not really exist or stored in the physical desks. And then let's see how to create a view. The grammar is created view. Here we can write we can give a view name, and here we write column name list. So this column list, if any, this list gives the attribute names of all the attributes of this view. Otherwise, the attribute names of this view are all target columns in the select statement in the subquery. And here, as subquery, this query can be any legal select statement, but we generally do not contain semantics components such as order by, union, or we don't use this kind of things in the subquery if you want to use it in the created view. And here we can see there is a with check option. And if you write a with check option here, that means the system will automatically check whether it meets the condition expression in the subquery of the original defined view when performing insert, update, and delete operations on this view in the future. So if you write the with check option during the definition of the view, afterwards, if you want to insert some tuples or delete or update some tuples, it will check if this tuple meets the condition expression in this subquery. Here, let's see an example. If we want to create an employee view of the department 02, that is, take a tuple of the department 02 from the employee table to form a view, we can use created view VEMP 02. Yes, here we write a subquery. We write select star from employee where the department number is equal to 02. So by this, you can select all the employees' information whose department number is 02. And then you can create a view for the query result of this subquery. And we can see that the above view is only derived from a single basic table from the employee and returns the original key. This view is called a row column subset view, and some books call it a simple view. And let's see another example. If we want to create an employee view of the department 02, and it is required to ensure that the view only have employees of department 02 when modifying or inserting operations. So here, if it is required to ensure the value to ensure the view only has the employees of department 02 when modify or insert operations. So here, except subquery here, you also need a with check option here. So due to the with check option clause in the process of defining the view, when inserting, modifying, and deleting the view, the RDBMS will automatically add the condition of the department number 02 and delete operation. Otherwise, the DBMS will not operate this code language and will return an error. And we can also see the views can be derived from a base table of view or from multiple base tables or views. When defining a view, if some derived attributes are set, that means these attributes are not in the original basic table and their values are obtained by using an expression to operate on the original basic table. Then the view is called a view with expressions. And derived properties are also known as virtual columns. So here we need to know that since the compute property does not have a property name, that means the column name, you must set an Alex for it at this time, or specify the column name of the view after the view name. So that means you can just give, for this example, you see, define the actual salary of an employee on the salary table. So here you can create a view here based on two tables, based on the employee and salary, these two tables. And we want to know their employee number, employee name, and actual salary. So here, that means we want this 3-column information to form this view. And here, the subquery we write is we just select the information of these 3 columns from the employee and salary table. So here, for the where condition, we use equal condition. And for the act salary, we compute by these columns. So as for this column, we don't have an attribute name. It is just expression. So here we give a name here. So you can give a name here or here, both okay. And views can be built not only on one or more base tables, but also on one or more defined views. So for this view-defined views, or we call it view-based views, or on the tables and views, it's both okay. For example, if we want to create a view of the employee's actual salary, if the employee's actual salary is greater than 2,000. So that means you need to create a view vSalary2 as here we need to write a subquery that writes select star from vSalary where the actual salary is larger than 2,000. And we can see here the vSalary is the view we created before. So here, this is the view we created here. So we can see we can create a view on a defined view. So for the vSalary tool, we call it view-based view. And when defining a view, if a query using set functions and a group by clause is used, the view is called a grouped view. For example, if we want to create a view that includes the average paid values of the department and its employees, we can write created view vDepart salary. Here we write the information of the department number and the average act salary. So here, if you want to know the average paid values of the department and its employees, we need to group by. We need to group by the salary based on different department number. So here we can write the subquery like this. You can select the DNO department number and the average salary of the average of the actual salary here from these two from a table employee and a view we created before. So here the condition is the employee's number should be equal to the employee number from this vSalary view. So this is also an equal function, equal condition. So here we use group by DNO to ensure that we have grouped different employees according to their department number, and inside a department we can calculate the average of the actual salary. And then let's see how to check and modify view basic information. The SQL Server allows users to obtain some relevant information, such as the name of the view, the owner of the view, and the creation time, and so on. And the view information is stored in the following SQL Server system tables. So we can see above these four are stored the view information, and the system objects store the basic information such as the name of the view, and the system columns store the columns defined in the view, and the system dependence stores the dependence of the view, and the system comments stores the text that define the view. So you can see in your SQL Server, can you find this kind of information, and can you see the view information stored in this kind of in this three place? And then let's see how to manage a view. You can use the system start procedure SP help to display information such as the view's name, owner, and the creation time. And you can also use the system start procedure SP help text to display a view's definition statement. For example, if you want to view the text information of the view, you can write execute exec help text v department salary, and this view is we just created before. And you can just you can just try these commands in your SQL server after you created a view like this. And if you want to see the dependencies between the views and other database objects can be viewed using the system start procedure SP depends. For example, if you want to view the dependencies of a view with other database objects, you can use exec SP depends v department salary. So you can just write these commands to see if it works. So next, let's see how to modify the view. So the statement for Mars is alter view, and here we write the view name and the list of the column names as the subquery. For example, if you want to modify the definition of the view v employee 02, of which we just created before, you can use alter view to means that you want to modify the view we have created. So alter view v employee 02. So here you can write as and a subquery here to show the query content which you want to modify. So here the query results of this subquery we can just modify the content of the view to the query result of this subquery. And then let's see how to delete a view. So the statement format is drop view, and here we write the view name. And this statement will delete the definition of the specified view from the view dictionary. And after a view is deleted, the data stored in the view space tables is not affected. But any query of other database subjects built on this view will fall because you have deleted this view. And if you want to drop a view, the drop view statement must be used. For example, if you want to delete the definition of the v employee to 0 view from the data dictionary, you can write drop view v employee to 0. And we can also modify the data in the base table through the view. But it has several restrictions, like I said before. So let's see what is the detailed restrictions. The first, the query on the view and the insertion, modification, and deletion of the records in the view all act on the base table. And a view can perform an update operation which requires the following condition. First, there are no aggregate functions and no top, distinguished, and group by and union clauses in the query statement that defines the view. That is, the columns in the result of the query statement should not be modified to the columns in the base table. Second, at least one table must be referenced in the from clause of the query statement that defined the view. And it should also be noticed that multiple tables cannot be modified in one modification statement. That is, the column names used in an update or insert statement must use the same table. And when deleting a table through a view, only one table of the view is required. That is, only one table is referenced in the from clause of the view definition. So you can't just delete multiple tables through one view. For example, if we want to do the additions, deletions, and modifications to the view, V employee to 02 will be converted to additions, deletions, and modifications to the base table's employee. So we can write insert into this view and into the detailed values for this. These values are corresponding to the detailed columns in this view. So you insert into the view is equal to insert into the employee table because the view is built on this employee table. So you insert the tuples in the view is equal to insert the tuples in the basic table. And similar, if you do this update operations, it is equal to update the tuples information in the basic table. It is also the same if you want to delete the tuples from a view, so it is also equal to delete the tuples from the basic table. So when defining a view, if the clause with check option is added when the view is updated, the system will automatically check whether the condition at the same time as the time of the original definition are satisfied. If it is not satisfied, it will refuse to execute. For example, we gave two examples to show the difference. First is if we don't use the with check option, with check option, we don't specify this in the view in the definition of the view. We can insert this kind of tuples. So we can see this view we defined is we required the employees of the department number is 02. So if we don't write a check option here, with check option here, we can also insert the values from the department number of 03. So if you write this SQL language to the SQL server, it will return right. It will return the output. The number of rows affects is one row. That means you have inserted this tuple successfully to this view. And if you have write the with check option during the definition of the view, then we can see that you cannot successfully insert these tuples to this view because it will check a insert or update by the view field because the target view or view spanned by the target view specified with the check option and one or more of the resulting rules of the operation does not qualify for the check operation constraint. That in this example, that means the department number 03, it is not 02. So this SQL language is not allowed, and the statement it will not successfully insert this tuple into this view. So the statement terminated. And we also need to notice that not all the views are updatable because some views updates do not translate meaningfully into the corresponding base table updates. For example, if you want to derive a view to find the average age of each department from the employee table, we can write created view v average age as here we write a subquery here to calculate the average age of each department. So we just group by the department number and we calculate the average age within the same department. We calculate the average age of the employees within the same department. And here we also give another name, give a new name. Any updates to this view by this statement cannot be translated into updates to the employee table because here we have used average. We have used an average function. So if you want to modify this view, you can't translate into the updates to the employee table. So let's review. In this class, we have talked about the data updates using the subquery. We also call it nested query, and we have introduced the view. It's including the created view, and the group by can be used in the query blocks, but order by clause cannot be used. And rows and columns subset view and non-rule and column subset rule we have talked about, and this one we also called simple view. And we have talked about how to query a view and how to update a view. And this is the new constant of this class. And then I will share the homework, the answers of the homework, the second homework by SQL Server. We have talked about the join, the inner join, the outer join among several tables. So if you want to query something which may contain the information in multiple tables, so you can use the inner join or the outer join. And we have discussed the difference between this kind of join. For example, for the inner join, we have talked about the inner join, the equal join, the natural join, and the difference you should know. And then we have talked about the outer join, and we have discussed for an outer join, you can limit it only one table and not other table. So this is different from the inner join. And we have discussed the outer join are divided into the left outer join and right outer join and full outer join. And we have shown the syntax of all this join. We can see the difference. The difference is that we use this different kinds of outer join to join two tables. And here I gave an example to show what's the difference. For example, if the department has no employees, that is, there is no employee tuple that matches it, then the employees of the corresponding department will be filled with a non-value. So if we want to query about this kind of example, we will use the following circle language. That is select dno, dname, and eno, ename, etitle, which these columns are from two tables, from this department and employee, these two tables. And we can use the left join to join these two tables. And on the condition of department DAO column value is equal to the employee DAO column value. So according to this left join, we can keep all the tuples of the department in the query result. And for the tuples which we can't match the tuples in department D with this condition, we will use a non-value for these tuples in employee E. So this circle language is also equal to select D know, D name, E know, E name, E title, which is the same with the above circle language from employee E department D, which we only use a dot, which means it's a cross join, and we show the condition of the left join in the where after the where phrase. So here we use DNO equal to star DNO. So this condition means the left join. So it is equal meaning. But we need to note that this equal star or star equal is not supported for the usage of outer joins in existing circle server words. So maybe for if you want to use this left join or right join, you can only use above this kind of writing. And the outer connector of several DBMS will be the simple plus. So maybe it's not the star, it's the plus, for example, for the oracle or other characters. They will use different, but the meaning is the same. And let's see another example. If we want to query the numbers of employees in a department where the employee exists, we can use the following circle language. We can use a simple inner join, which is like this, is select the name and the count, which means we need to count the we need to count the number of the ENO from department D join employee E on the condition of DNO is equal to E DNO, and we need to group by D name. So what's the meaning of this circle language? First, if you want to query the numbers of employees in the same department, you need to group the name according. You need to group the whole department according to their name. So the employees in the same department will be grouped in the same group. And then you need to use the equal join, also the inner join, to just connect these two tables together, to connect the department D and the employee together. And then you can just select the D name and count the number of the employees, that is the number of the different ENO in different groups. And let's see the difference. If we want to query the number of employees in all the department, then we need which kind of query language? Let's see. Because for this kind of query, we need to contain the query results, need to contain the data related to the department without the employees. So that means if for the tables for the department, they have no employee, we also need to show the information of the department too. So for this kind of condition, we need to use the left join to remain the information of department. Although for the department they have no employee, we also have to remain it. So for this kind of for this situation, we need to use the left join. And for left join, we can just use this kind of circle language. Select D name, count E number. So this also is count the number of the employees according to different department. And for the department where there is no employee, we also remain its information here. And for this kind of department, their employee information will be none. So for these two kinds of query language, for this one, count in O is equal to count star. So it means for this each tuple, you can count in all or you can count other kind of columns. It's okay. It's all equal to the count star. But for this kind of thing, because there exists some department, there may exist no employee. So if you want to count the number of employees in all the department, you will use count in all, not count other columns. So for this situation, count in all is not equal to count star, because count star will count the existing department, which may larger than the number of employees. And then let's see what is self-join. And the self-join, we can see is the join operation is to perform a self-join within the same table. So that is to join different rows of the same table, which we call self-join. So it can be regarded as a connection between two copies of one table. You just specify two Alex for the table to logically become two tables. Since all the attribute names are attributes with the same name, so you must give each column Alex prefixes. So you need to refer to you need to give there another name to refer which table, which column you are referred to. So for example, for this example, if you want to query employees with the same surname in the employee table, you can use the following language, which is select EI ename and E2 ename, which we do a self join between the table between the table employee. So we just give the employee two Alexes, so which we call the E1 and E2. So we can do a self join between E1 and E2. We can use select E1 ename and E2 ename from the employee E1 join employee E2, which we call the self join because it is from the same table employee. So the condition is on left E1 ename dot 1 is equal to left E2 ename dot 1. So this condition means you want to search the employee's name with the same surname. So the one is about the surname. Okay. So left one is about the surname. So which we also found put it on the first place. So where here we use E1's is now is smaller than the E2's which we refer to the name the name of the employees which we want to query is just with the same surname but not with the full name. So here we use the ENO to identify these are two names, but they have the same surname. So for to use this circle language, you can just query the employees with the same surname in the employee table. And here, after we have discussed all these query, this inner query, outer query, self query, self interjoin, outer join, and self join, we can discuss the site operation because the query result of the select statement is a connection of tuples, right? So the results of multiple select statements can be aggregated. So to aggregate these results of these multiple select statement, we can use these connection operations. So it's depend on the detailed connection operations. They depend on a set. Maybe it's a set operations depend on the specific RDBMS. So normally we use union and intersect and except our manners. First for the site operation union, it means if you use the union statement to combine the result size generated by two or more query results into one result set. So the grammar is select list. Here we will also use the columns union the select statement. So here if you want to union the results from two select query phrase, the columns involved in each query in a union must have the same numbers of columns, the same data type, and appear in the same order. So you can just union these two set of query results together. And also after union the query result from these two sides, the column names in the final result set comes from the first select statement. So if the union contains a order by clause, the final result set will be sorted. And when using union to merge result sets, the default is to remove duplicate rows from the final result size, unless the OR keyword is used. So if you use an OR keyword here, it means you want to maintain all these duplicate rows, duplicated tuples in the query result. And also, let's see our example. For this set operations, union insert, union intersect, except we can use select star from employee where title is equal to engineer. And here we can use union to pull the query results from these two select these two query together, or you can use the intersect or the except to just obtain the other results from these two sides. So we need to know that for the intersect and except, it is different from union. It is supported in higher version of SQL server. So after we have discussed the select where from this query language for one table, multiple tables, and the set operations, let's discuss and let's introduce the nested queries. We also call it subqueries. So what is a subquery? Which we have divided into uncorrelated subquery and the correlated subquery. And let's see what is an uncorrelated subquery. That means the execution does not depend on the outer query. and the inner query does not depend on the outer query. So the subqueries can be used multiple times, and there are two types. The first is the subqueries that return a single value, and the subqueries that return a list of values. So these are the two types. One type is a single value, and another type is a list of values. So if it is returns a single value, which is used by the comparison operation of the outer query, which it can be the value obtained using an aggregate function in a subquery. For example, we can use count star or aggregate function or minimize function in a subquery, so we can get a value as a result in the subquery. So if you want to return a list of values that are queried by the in, not in, and or this kind of comparison operations you can use. And for these operations meaning in means belonging and not in means not belonging. And or are used to compare one value to another group of value. So let's see several examples. First, let's see if we want to query all the employee numbers, names, and titles that are participated in the 2009 and January project, what we will write as the query language. And we can see for the employee, its numbers, names, and titles, which related to the project. We can't find all this information in one table. We need two tables. We need the employee and we need the item and employee, the relationship. So if you want to query the above information, first you need to know which employee are participate in this project. You need to know the employee number. So here the subquery we used is select know from item EMP, this table, where the condition is the item number is 200901. So by this subquery, we can obtain the employee number which participate in this object. And we need to know, we need to obtain the employees numbers, names, and titles. So we need to search this kind of information in the employee table. And here, the employee, we need their number in the domain of the employee number which we found in this subquery, which we can ensure that all these employee numbers, names, and titles we return here are the employees' information that participate in this project. And also another example, if we want to query about all the projects that employee 1010 does not participate in, we can use the following circle language. We can use select star from item where the item number is not in. Here we use a subquery, which we use select item number from item EMP where the item number is 1010. So here for the subquery, we use this circle language, means we want the project number which the employee 1010 participate. And for if we want all the projects that this employee does not participate in, we just pick up all the information from the item where the item number not in the query result of this query. So we can obtain this information. And if you can be sure that the return result of the subquery is always a single value, then you can use an equal. This equal instead of in. So if we want to use in, also means a domain, a list of values. So if you always ensure that the subquery will returns a single value, then you can use this equal, or you can use this you can use smaller than or larger than, or just this comparison operations is okay, because this comparison operations can use on this single value. For example, if you want to query the employees which participate in the project, call this name, you can use this subquery. You can use this subquery. First, you use a subquery to select the item number whose name is this one. And after we have this number, you can select the employee number, which is item number is the one we found in this subquery. And after we have these employee numbers, we can select all the employee information from the employee table, where the employee number of these employees are in this returned employee numbers. So here we can find that if you can ensure that this subquery can return to a single value, you can use an equal, because for each item name it always corresponding to one item number. But if for these item numbers, each employee may participate in multiple items. So here we also use a in to represent that this subquery may return a list of values, which means a list of item numbers. Not item numbers, a list of employee numbers. So here we use in. So it means for each item, we can have several employees participate in. So for the subquery, we can use these comparison operations such as this kind of operations. For example, if we want to query the names and ages of all the employee older than the average age, we can use select a name age from employee where age is larger than the ones which comes from this query. Select average age from employee. So here we use a subquery, and we know that for this average age, it must return to the single value. So we can use larger than operations here. And here we need to notice that the aggregate functions must not appear directly in the where clause. So you can't just use the average functions here, but you can use it in the having phrase or in the subquery or after the select keywords is both okay. So you can't just use this kind of circle language which you just write the aggregate functions here inside where clause. It is not allowed. And here, we also need to know that the comparison of operator can also be used with NA or OR, and NA only needs to match one value in the subquery, and OR needs to match all the values in the subquery. For example, if we want to query the information of employees in the non-true department whose age is greater than the age of any employee in number 2 department, and we need to sort them in an accessing order of age. So we can use this kind of select language, and we can use select star. Means we select all the information from employee where the condition should be age is larger than any age returned from this subquery. So this subquery is select age from employee where department number is equal to 02. So is larger than any age from any age of the employee in department number 2. So we can use this phrase. And also we need to make sure that the department number is not 02. So we use this operations. And we need to sort them in an accessing order of age. So here we write order by to just sorting the query results. So this subquery is also equal to age is larger than select the mean age from employee where the department number is equal to 02. So these two query language is equal, and they will return the same query results. And here, we can see the subquery with NA or predict. And NA and or predict can sometimes be implemented with aggregate functions. And this following table are the correspondings between NA and OR and the set functions. So we can see it's smaller than means for the NA predicts is smaller than the max, smaller than the max, and for the OR smaller than is smaller than the mean value. So let's see how to use the between and in the subqueries. And between and, which we have discussed before, we can use it in a query language about one table. So we can also use the between and for these subqueries. For example, if we want to query the basic salary between the salary of the employee number 1010 and the employee number of 800 yuan, and we can use this kind of language. That means select first even all from salary first, salary first, which means we just give the salary table to Alex Smith first and second, and the condition is where the base pay between what? Between the salary of the employee number 1010. So we have this query subquery using select base pay from salary second, where the second employee number is 1010. So here we can select the base pay under this condition, and between and the employee number of 800元. So we just write between this subquery and 800 here as the condition for the author select language. And these things we have talked about are the subqueries of uncorrelated this condition. So these are uncorrelated subqueries. And for the correlated subqueries, it means the execution of the subquery depends on the author query. So most often, the tables of the author query is referenced in the where clause of the subquery. So you can use the exist keyword to determine whether there is data in the query results. So exist is true when a subquery returns at least one row. So here we can see the query, the number and the name of employees who participate in the project. We can use this kind of select language, which we use exist here. So it means if we can use this subquery, it returns at least one row. So this exist is just true. So it will return the row of the rows also is the query result of this query. And for this result, we can just for this result of the subquery, we can just select the e number and e name related to them. So here we can see the process of this query language. First, we need to make sure that this subquery is not empty, so the exists will return to true, and then return to true, and then this author select query will take out the result set according to the result returned by this subquery. And here, let's see the result. Let's see another example. If we want to query the employee number and the employee names who have participated in all the projects. And here we need to know that in the item EMP table, there are no records related to the items that employees does not participate in. So this is the same meaning. So if we want to query this kind of information, we need to write to not exist phrase. So for the first, you need to write a subquery to select the records that are related to the items that have employees participate in. So if not exist, it means you want the information of items not exist in the query result of this subquery. And here we also need another not exist to refer to the this subquery means here there exists the items which have no employee participate in. So we have another not exist to represent that there is no records related to the item that the employees does not participate in. So this not exist is referred to this. does not, and this not exist is referred to no records. So here we use to not exists. And let's see another example. If we want to query the employee numbers and employee names who participate in all the 2009 projects, we can also use this to not exist. And for the subquery, it is the same, similar. We can just select all the information that we have the employee participate in these items. And we have the not exists means there is no records that have this employee participate in. And we have another condition is 2009, so we write the item number is like 2000, and we use this percentage keyword to represent we need to search this kind of string like 2008. So here we also use another not exists to represent we want to query the employee numbers and the employee names which are not participate in any name in any item names numbers are like 2008, not like 2008 products. So here, after we have discussed all these functions of the select, select about the query, we start to learn how to create new table based on a query. So we have introduced that a new table can be created based on a column, based on a row, or on a query using the select into language. So the select into statement first created a new table and then populates the new table with the results of the query. So here you can just use select list into new table from table source. Here the following is the same we have discussed. Let's see this example. If we want to create a new employee table for all the employee with similar titles, so we can use select in all in name in DNO into this table. Similar engineer this table from employee where title is equal to senior engineer. So let's give a review for this class and the last two classes. We have talked about all the circle language, including the DDL, the data definition language, the DML, the data manipulation language, and the data control language. So we have discussed how to adding, deleting, and modifying data in the table using this insert, update, and delete keywords. So we just focus on the data query in a table. So we always use select for the single table query complete snacks, and we use this kind of we use this kind of snacks to query the information for the same table. And the keywords which can be used in the where clause is in and between and like. And we also learn the usage of select into. And by using the selecting tool, we can just update the tables with the query results. And we also learn the multi-table join query and the join condition, how to write it. And the join is divided into cross join, which we normally not use it. And we introduce the equal join and the nature join and the not equal join and the inner join, which we normally use. And we have introduced the outer join, which includes the left outer join, the right outer join, and the full outer join. And we have discussed the self-join, which means to join two or more queries of the same table. And we have discussed the subquery, which contains the uncorrelated join, uncorrelated subquery, and correlated subquery. And for the uncorrelated subquery, we can use in between comparison. So in the last part of this class, I will share the answers of the second homework by this SQL server, and we can see in my screen I have download and used the SQL server 2019, and in this screen we can see that I have downloaded a SQL Server Management Studio, and we called SSMS. So if you want to use the SQL Server in this graphic screen, you can also download SSMS. And in my screen, you can see that for these two tables, four tables. We can see here in our homework, we have it's not four. Yeah, it's four tables, and the first one is it needs to create four tables with a SQL statement, and you can see that I have created these four tables here. Is class and course and grade and student. So you can use the created table course. Here you use for each column. For example, if you want to create a student table, you can use created table student and their as number char 7, and if it size unique, so you can use a primary key or unique, and then you can write as name, and if it is not allowed to be none, so you can use not none. And let's show you an example here. If we want to create a table, you can just click the new query here, and you can just write created a table, for example student, and here we use SNO char 7. So if you here we can see the SNO is the primary key of this table, so we can use primary key here. And for S name, we can just write vchar here. So it's no matter you use collapse or just use this. It's okay. So it says it is not allowed to be none, so you can have the not none here. And for the SX, we can write per 2, and it is not allowed to be none, so we can also write a not none here. And SH starting, and as it is allowed to be none, so here we don't need to write anything here. And the last column, class name, class number, so we can use here, we just copy, and it is not allowed to be none, so we write not none here. So we can just create a table by using this. And as I have already created one, so I just show you the language, and I will not execute it, as I have already built this table. And after you run this, you can just click this execute to run this. You will just create a table by using this SQL language. And after you create all these 4 tables, you can use the insert that comes to the insert tuples. You need to insert these tuples in these blank tables, right? Because after you created a table, it only has the definition of the table, but there has no tuples in this table. These tables are blank, so you need to insert several tuples, these tuples in these tables. So you can use insert into, for example, insert into student, insert into student. Here you can use values, and you can just click and here just remember to write here. Okay, so you just need to write this. And here we need to know that for the date or numbers, you don't need to write this. You don't need to write this on these numbers. So here, you can use this SQL language to insert this piece of tuples into the table of student. And here we can see it says involved object name student, and it is not true, so you can just ignore it. And let's see. So it says, okay, I have dot this, okay. Let's run it, and it says it is involved object name student. So that's because I have insert these tuples. So as I have put a primary key on this student number, so I can't just insert into the same tuples in this in this table. So let's see. So let's see, I have already insert these tuples here, so I can't insert into another table. But if you are not insert to it, so that is okay. You can just insert using the insert into values using this. So here, if you want to insert multiple values, you can just write okay, you can just write another tuples here. So by this, you can just insert multiple tuples once at one time. And then let's come after we have built these tables, we can just run these queries. And let's see in the question 2, the first question is add an attribute nation to the student table, and the data value is vchar, and how to write it. We can use this author table student and add nation. Add nation, this column, the data type is vchar, so we write here and execute. Oh, it says it does not exist, so we can just execute it into this database. Okay, let's see. And we can see first we need to build a new query on the database of grid manager, which we have built, which we have created these tables in this grid manager database. So after we created a new query on this grid manager, we can use this SQL language to add an attribute nation to the student. Okay, you can see that after I have add the column nation successfully, I can't add anymore. So it says the column name in each table must be unique. So for the second one, delete the new added attribute nation in the student name. You can just use author table student and delete. The delete function we use is drop column nation. So here, let's execute it, and it says it has completed successfully. And let's see in the student column, let's see, we can see it doesn't have the nation row. Okay, so I just run it once more, and to show you we have successfully added this column nation. And after we use this drop column nation, we can see here we need to refresh, and we can see the nation is disappeared. And the third one, insert record, we have talked about. You can use the insert into grid values, this one. So you can just insert this record. And for the first one, modify the score of the student whose student number is here is this one 270. So you can use the update. You can use the update language update grid that gmark is equal to 70, where SNO is equal to, yeah, it is this one, right? So here at parent gmark, right? Gmark. So here we can see that we have update the score of the student whose student number is 2001110 to 70. And for the fifth one is delete. Delete, you can use the delete. You can use the delete grid from grid where from grid where SNO down here is equal to here. So here you can just run it to delete, and let's see what the grid shows. So we can see that as I don't have this record, so you need to just insert this record, and then you can use this delete and modify function. As in my table, I don't have insert this record. And for the sixth, to create an index name X class for the student table and sort it in accessing order by class CLNO, you can use also created index X class on the student table and the class number column with the accessing order. Here, so you can use this, and it can see it is complete successfully. That means I have built index here, and we can see on student indexes here, we can see I have built an index here. And for the seventh, to remove the X index, so we can just write drop index, and as it's from student, so you use student here, and it means you have delete this success, the index success. So let us refresh and see. So the index we have just built is disappeared. We have deleted, right? And for the third question in the first, find out all the course numbers that the student have taken. So that means we can just find the student taken course numbers in the which one, in the grid table, and we can just see how many types of how many types of courses in the grid table. So that means all the course numbers that the students have taken. So you can just select. To remove the distinguished duplicate course number, because for one student it can took more than one courses. So if you want to find out all the course numbers, you need to remove the duplicate ones. So we need to write a distinguished keyword here and from the grade table. So we can run this and let's see in the grade table, the number 1 to 6, we have the A. Let's see. Maybe the column I have built is a little different from the homework I gave you here. So it's a little different. I see here I have the course 7. So according to my table, the query result is 1 to 7. Is 1 to 7. And for the second one, find out the personal information of female student in class 01311. So you can use select. You need to select all the information because it is not specify any columns of the table. So you can just use a star here. And from the student table, where the class number should be what? Should be this? Should be 01311, and it says the female student, so we need to give the exercise condition be female. Here we write a new. So we can execute that. We can see that here we got a query result here. So you can see, do you got the right answer? And for the third one, find out the names, genders, and birth years of the student in class 01311 and 01312. And I see some student in the Dean talk has taught that in our table we don't have this 01312. So it will not search anything about these classes. It will only search this one. So how to write that? We can write it normally. Select as name. Select as name. Gender, so it's right as 6. And the birthday years, as we don't have the birth years, but we have the age of the student, so we can write 2022 minus as age. So we give it as it is expression. It don't have a column name, so we give it a column name as birth year. And here as you can automate it from student where as name is equal to 1011, and here you just know that you can use or here, but you can't use the NA here because we can't find the tuple. Its class number is here is 01311 and 01312. So here you can't use an and here, but you can use an or. To represent, we need to search the student information whose class number is this, either or this. So here you can see that all these let me show you. This is the answer of the classwork, and let's see if you want to query the class number. So we can see I give it here as the birthday year, so it is not true. We can see if you don't give this expression name, it will return that no column name. Okay, so let's see this one. So it's not true. Yeah, I think this one. Okay, so we got all this query result is from 01311. So we got no result from this class. We don't have this class. And let's see the first. The first, find out the personal information of all students with the last name Li. So how to write that? As you can see, it is a search which you don't know the complete name of this student. So you can use a lag. You can use a lag from student where the S name lag. So you can use Li and percent here to represent. It can be any name here. And let's run. So we can see this is all the information of all the students with the last name Li. And for the fifth one, let's see, find out the names of students in Li Yun's class. So this one we can see that the student and class information is from two tables. It's from the class, and it's from the student, right? You need to know the student information and you need to know the class information. So you need to join the information from two tables so that you can query both two. So you can either use class select number from class and student, and where we put the condition, the join condition here is equal to student dot CLO. And another situation is the S name. The S name is Leo. So here we write Leo. So for using this, it is inner join, which we use this join condition here, and this is another condition. And let's see, if it executes that, it will return the number of students in Leon's class. And let's see if it is correct. We can see Li Yun is in 00311 this class, and for this class 00311 it has 120 students. So here we have got the right answer. And let's see the sixth. The sixth is that we select find the average has the lowest grade for the course named 操作系统. We call it OS, operating system. So we can use select average because we need the average store. So we can use average gmark and max. We can got max store. So we give a max gmark and mean gmark here as we use this function, so we don't have attribute name, so we give it as the attribute name as avg, max, and man. And from the grade and course, and we can see it is also the information should comes from two tables. So we need from two tables, and here we tapped the condition. The join condition is normally we use the primary key and the foreign key as the join condition. And the C name is equal to 操作系统. So here we can see this is the average score from these two tables where the C name is 操作系统. So do you got the right answer? And let's see the seventh one. Find out the number of students who have taken the class. So it is also very simple. You can just count how many students have taken this course. So it means any course. So you can give it another name from grade. So we can see we got six. We got six number of students who have taken the course. So let's see in the grid. We can see we got how many students who have taken the course. So we just count how many students have different student number is okay. So we just use a distinguish to remove the duplicated ones. So we can see we have 1, 2, 3, 4, 5, 6 students. Of course, this one we have 6 students. 6 students. Here is 1003. So maybe it's different from my table. Right here, in my table, I have got 6 students. Here you can see that 200103. This is also 200103. So we got 1, 2, 3, 4, 5, 6. We got 6 because this one is the same with this one. So we got 6 students. So the one returned the results is correct. But if you query this table, you should return 7 students. Okay, so let's see the 8th one. Find out the number of students who have taken the course 操作系统. So you can either use the join. You can use this join, inner join as number from from the grade and course table where the join condition is CNO is equal to course CNO and the CNAME is equal to操作系统. So here we can have 3 students who have chosen the course of 操作系统. And let's see if it is correct. We can see the CNO corresponding to 操作系统 is 4, and we can see in the grade table for the CNO is 4. We can got 1 student, 2 student, and 3 student. We have 3 students have selected the 操作系统. And you can also use the subquery to get this query results. So you can see that as number, I'll give another name from grid. You can also by using a subquery which you use a subquery to select the course number of 操作系统 or operation system first. So here you can just use a subquery here, select CNO from course table where the CNAME is 操作系统. Okay, so you can see the conflict. Maybe it's a little small, so I write it here. So you can see that you can see that this is the subquery here. That means you select the CNO corresponding to the 操作系统. And here, as we know, this CNO it will return only 1 value. So we use equal, and by this we can get the course number of 操作系统, and we can just count. How many tuples where the column number is 操作系统. So it's 3, and let's run. We can got the same answer. And let's see finally one is find out the names of students with non-grade in 2000 computer software class. And how to write this. And we can see if you want to know the names of the student with non-grade, it means the G mark is none. They got a non-star. And we can see here for this table, all the students have star, right? It has no none. So here, let me see. Let me give 2 columns none to see how to write this. Circle language. So here we give this 2 and none, and let's see how to query that. So here, after I gave this none, we can see we need the information from student because we need the names of student, and we need the course. we need the grade because it is related to the score, and we also need the information from class because it has the information from class. So here we have make sure that we need the information from 3 tables. So we need to either join it together or use a subquery to query the information from different tables. So here you can either use join selection. You can use a join here from these 3 tables, from student and grade and class, where student SNO is equal to grade SNO. Here we also use the primary key of student and the foreign key of grade as the join condition. And another join condition is CLNO is the class number. So it is the class. So it is the CLNO is the primary key of class. We use this. And another condition is the specificity should be计算机软件哈 computer software, and the coming in year should be 2000 right here. So here you need to write 计算机软件 computer software, and the income in year is 2000 and the G mark non-grade means the G mark should be none. So here we need to notice that you can't write equal. You can't write equal here because none is not a value. So you must use an is here, or is not none, is not here. So here, let me show you the complete circle language here. So you can see the complete circle language is here, and let's execute it. Okay, we can see we got 2 students here, right? So we can see these 2 students who got none is here, is this number, and this one, this number. So you can see if it is corresponding to here, Li Yong, and here, Jia Xiangdong. And we can see they are from this 00311 and 01311. And we can see, so here we can see it is from different in year. So this one is from 2001, and it is not correct. Let's see if I have got the right table. We have got the right table information. So let's check the class. All right, because I have input the in year is 2000, so I got 2 query result is Li Yong and Jia Xiangdong. If you here, you just tapped 2001, so you can just got 1 result is Li Yong. So that is all the answers of our second homework. If you have any questions, please leave a message to the Dean Talk. And sometimes if I can't reply, I will try to reply it in time. That's all. Thank you.